All right, so talking about scatter plots. Today, talking about line of best fit. You've been working on a science project for months, for 8 months. Each month, you measured the length of a baby alligator. The table shows your measurements. So whatever month you're starting in, September in this case, is going to be month 0. That's your starting month. And then 1 month later, what comes after September? October, then November, December, January, February. Okay. So the crocodile is growing up until you stop measuring in April. That's probably where it is right now. It wants us to graph the data to start with, so we can go ahead and do that. And as you might have noticed, there's another break in this graph because at no point was the alligator ever 0 inches. In fact, when it was born, it was already 22 inches. So that at least when we started measuring it, it was 22 inches. So we have nothing below 22. So that's why they didn't include any of those numbers on the y-axis, and they broke that graph right there. So we're going to plot 0, 22, 1, and then 22.5. 2, and I'm just going to do bigger dots. Let's do that. 2, and then 23.5. Then we have 3 and 25. 4 and 26. 5 and 27.5. 6 and 28.5. 7 and 29.5. All right. It says draw a line that you think best approximates these points. Now I know that this isn't a perfect line, but we said yesterday we would have said this is linear. Is this positive linear or negative linear? What do you think here, Xander?
Positive.
Yeah, that slope's going to be positive. As the alligator gets older, its length is increasing. Now that won't happen forever. So at some point this would end up being non-linear. It would stop growing, just like you're going to stop growing at some point. You're not going to be 82 and 8.5 feet tall. So in fact, they say when you're older, you get shorter. I guess maybe just because you have more of an arch in your back. But anyways, go ahead and draw what you think your trend line would look like right here. I'm going to go ahead and start it at that point, and then I'm going to give my best guess as to what this would look like. It's pretty close. We'll just go with that one. So one of the things you'll notice, I have about just as many points below as I do above the line. And so that kind of splits my data like that. Okay, so I've got my trend line drawn, and then it wants me to write an equation for my trend line. Now, anytime it asks you to write the equation, just know that your equation needs to be written in slope-intercept form, or y equals mx plus b. Then a little bit since we worked with that, but that's going to come back and be a major player in our chapter this time. So it wants us to write the equation. To write the equation, I have to know 2 things. I have to know what my m value is, or what my slope is, and I have to know what the b value is. What's the b value stand for? Owen? Y-intercept. Owen, what is our y-intercept of my line? 22. Okay, so I know it's 22 for b. And then the x, or the slope, at least the slope of the line I drew, is going to be really close to rise 1, run 1. So that would be 1 over 1 or just 1. And so I'm going to go with the equation y equals 1 or just x. 1x is the same as x plus 22. That would mean my initial value, 22, when I started measuring, the alligator was already 22 inches. And then my slope tells me how fast the alligator is growing, which is currently about 1 inch per month. 1 over 1. 1 y over 1 x. 1 inch per month. It wants us to use the equation to predict the alligator's length next September. How many months are going to have gone by if we started in September and we want to make a prediction for next September? Julia? 12 months. So instead of trying to figure that out by looking at the graph, which I could because 12 is technically right here and it'd be wherever the line hits that, instead we could use the equation. And we've done this before. Is 12 months my X or my Y? Christian? It's the X. Yeah, the X axis is my months axis. So we'll just plug 12 in for X. Oops. Add 22 because it's already growing, or it's already had it, I guess, started at 22. And how long is the alligator predicted to be a year after we started, Christian? 34 inches. I like how you labeled it. Nice job. And you could make that prediction for any of the months. If I go to my graph here, it looks like my line would intersect somewhere around this area, which would be close to 34 inches, right? So I could use the graph. The graph is going to give me an idea. It may not be completely accurate. Also, if I would have said, how about 2 Septembers from now, you wouldn't have been able to look at the graph. You would have had to only have used the equation to get that number. All right, so a line of best fit, or a trend line, as some people refer it to be, a trend line, is a line drawn on a scatter plot, close to most of the data points, about as many points above the line as below it. It can be used to predict data on a graph. It can be used to predict data. Let's do an example of that predicting right here. You're studying bat populations and predicting the number of bats that will be living in an abandoned mine after 3 years. To start, you find the number of bats that have been living in the mine during the past 8 years. The table shows those results. So 7 years ago, as far back as your study goes, there were 327,000 bats. Do you think they counted all 327,000 of them? Probably not. There's actually a way that you can predict the number of species in an area, or the number of, I won't say species, but number of animals in an area. And it's using proportions by finding a sample of them. So like what they'll do, and they do this like in ponds, by the way, they'll like tag like fish or something like that. Or maybe you've seen animals that have bands around their legs or their antlers or something like that, and they'll try to tag them like that to keep track of not only where they move, but also how populated that area is. And so they'll tag somebody, and then they'll go out and randomly see if they can find how many are tagged, and they'll use that ratio to create a proportion to predict the entire population of that species. So there's a way that they do it. Okay, so I'm guessing they didn't count individually by some sort of recording that there's 327,000 bats, but they just predicted that. So we're going to graph 0 and then 327,000, which would be somewhere in this area. Of course, it's counting by thousands. And we see a break here because there aren't any population of bats that was ever below 110,000. So we can just eliminate that whole part of the scale. And then 1 year later, there was 306,000. Again, these aren't completely accurate that I'm graphing here. I mean, that might be where 306 is. It might be where 304 is. I'm too close to tell. They're counting by 20s here. So 2 years later, 299,000 bats. Year 3, 270,000 bats. Whoa. Let's try that again. 270,000 bats. That was a pretty big drop off there. 254,000 bats for year 5. No, year 4. 254,000 for year 4. Through 232,000 for year 5. 215,000 for year 6. And for year 7, 197,000. Okay. So it says draw a line that you think best approximates the points. Go ahead and draw what your trend line would look like. And then we'll compare it to see if it looks like mine or maybe anyone else's. So again, you're drawing your trend line or your line of best fit. You want to try to have as many points above as below the line. Could be some exceptions to that. There could be outliers that you may want to ignore. I wouldn't say that we have any outliers in this data because the points are pretty close to lining up. What kind of trend would this be? Positive or negative? Sky? Negative, yeah. So as one thing is increasing, in this case, the time, as time goes by, the bat population is decreasing. Does your trend line look something like this? My notability, like auto corrected that to like form a 45-degree line. I don't have as many points above the line as I do below, so maybe I should try to fix that. Maybe a better trend line would be something like that. I think either way, they're pretty close. Okay, mine's starting at 330, although technically it's supposed to start at 327. Okay, it says write the equation. I'm going to go ahead and just start at the one that says 330. Because they're not telling me that it for sure goes through 2 points. I think it'd be easier to go ahead and do the first one I drew, just because that's going to be a lot easier slope to calculate. It may not be the best trend line, but it might be the easiest way to find the equation of a line that's very similar to the best trend line. And so it's going to have a B value. In my trend line has a B value of 330,000. And then its slope looks like it's going down 1. Now remember, going down 1 isn't really going down 1. What are they counting by here? Carson? Counting by, but each time you go down 1, how many thousands are they? There we go, 20,000. So yeah, so going down 1 is going down 20,000 over 1, or just negative 20,000. So my trend line is going to have an equation of y equals negative 20,000 plus 330,000. Your trend line would have a different equation. So what we're going to do on our homework, because you can't just like randomly be saying, well, this is my equation and it's not the same as yours. To make sure we all have the same answers, on your homework, they're going to tell you, use these 2 points for your trend line. They'll say, okay, what's the equation of the line that goes through these 2 points? We've done that before, and we got some examples. We'll look at that here in just a moment. Use the equation to predict the number of bats in 3 years. So 3 years from now, this is year 7. 3 years from now would be year what? Year 10, yeah. So we're going to use 10 for our x coordinate. We want to find out how many bats there's going to be in year 10, 3 years from now. This is, our study goes back 7 years. So we plug in x. Oh, I forgot the x. Hang on a second. Whoops. There should be a negative 20,000 x right there. Yeah, that's a way to lose a point right there. We're going to go ahead and plug in 10 for x right there. And that's going to give us negative 200,000 when you just add a 0 to negative 20,000 plus 330,000. And can someone tell me how many thousands of bats that's going to leave us with? Shane? Yeah, we can predict that there would be about 130,000 bats if that trend continues. Is it going to continue? Well, we're not sure. It's 3 years in the future, but we're just going to go off these predictions. So this stuff that we're doing right now, because most of you are like, okay, I'm not going to be raising alligators or counting bats. I get that. You're not Bruce Wayne. But you might actually be working for a company that's trying to predict how many items to have in their inventory come the month of August, right? Yesterday, we looked at a problem where it said as sunglasses increase, sunglass sales increase, the beach towel sales increase. Well, how many beach towels, how many sunglasses do I need to have in stock when it comes August, July, whenever those hottest months are? Well, let's look back at previous data and let's make a prediction based off the previous data as to how many items I should keep in stock right now. So the last thing you want is not to have enough items and people are wanting to purchase them and you're not getting the money because they're going to go somewhere else and purchase them then. And so if you work at a company, if you're, the manager, general manager, whatever, you'll have to look at previous data points to predict what you think is going to happen in the coming months or coming years. Okay. Yes. Yeah, you don't want to have too much. That's a good point. Nobody's going to be buying 40 beach towels in December, right? Which is why they go on sale, right? Because they're trying to get them out of their inventory and still get something for them without completely having it be a waste. Yeah, it's true. All right, next one. The table shows the depth of a river X months after a monsoon season ends. Write an equation for the line of best fit. They've graphed the line of best fit for us, so we have to write the equation of the line, and that's obviously going to be in slope-intercept form. What is the B value or the Y-intercept of our line, Chloe? What is that? 20, okay. And Jimmy, what would the slope be of our line? You got it. Yeah, it's going down 2 over 1. So our equation would say y equals -2, x, don't forget the x, plus 20. Now the x variable we're talking about is months. The y variable is feet. So when Jimmy says -2 or -2 over 1, he's saying it's going to go down 2 feet. That's the y value on top over 1 month. Okay, so keep that in mind. So the river is decreasing, or it's going down because the monsoon season has ended, it says. So, I think I just answered part B. So the slope means that it goes down, recedes. Is that the word I want to use? Does it recede? It means go down, right? Recede. I'll just say go down. Down 2 feet per month. And then what's the y-intercept mean? Chloe said it was 20. What does that mean? Brady? Not at the start of the year. When we started measuring. And when did we start measuring? At 0, when the monsoon season had just ended. So after it just ends, that would be after the last rain probably, right? So it had an initial value of 20 feet. I'm sorry, 20 inches. No, it is 20 feet. The last problem was inches. Okay, 20 feet. And we'll say at the end of the season, or technically you'd say at the start of our calculations. But we started calculating at the end of the season. Predict the depth in month 9. Okay, well, let's look at the chart because we can definitely get month 9 from the chart. How many inches is that? Sky? 2 inches. Yep, we can say 2 inches. And does our equation back that up? Let's find out. If we plug 9, let's try to do this better. In for x, because x is the number of months, we'll get -18 plus 20, and we get 2 inches. Maddox. Why do I keep saying inches? You're right. Yes, it's definitely 2 feet. 2 inches is not a very deep river. And 2 feet's not a very deep river either, but that's the very end of the season probably. I mean, think this trend's not going to go down that way forever because eventually it's going to be monsoon season again, and we're going to see that go back up and then back down, back up and back down. All right, you've heard me talk about correlation. Correlation refers to how closely 2 variables are related. We talked about positive and negative correlation. We've also looked at no correlation, but there is strong positive correlation where the points are very close to making a line. Then you've got strong, you got weak positive, which means I could still draw a trend line through that, but the points are going to be farther away. They're not as closely as associated. Then you've got no correlation, which means you couldn't even draw a trend line. Like I have no idea if I draw my trend line going up or down or straight across. And then we've got weak negative, and then we've got strong negative. The stronger the correlation, the more of a relationship those two variables have, the more closely related they are. So positive correlation. Stop doing that for me, Brady. Positive correlation, as one data set increases, the other set is going to increase. So increases. And also, you could say positive correlation is as one data set decreases, the other set decreases. So positive correlation is going to have a positive slope. Well, how do you get a positive number? Number slope's a fraction. Either they're both positive or they're both negative. Because what's two negatives make? Positive. Exactly. So you could reverse it, say as one goes down, the other would have to go down. That's still positive correlation. Negative correlation, they're going to be going in opposite directions. As one data set increases, the other set is going to decrease. And as one data set decreases, the other set increases. If you're going to have a negative slope, one of the numbers has to be negative. And it doesn't matter if it's the top number or if it's the bottom number. So you could say one's going to go down, the other one's going to go up, or you can put the negative on bottom, so the other one goes up, the other one goes down. And so either one of those would be a negative correlation. So we're going to look at some scenarios here, not some graphs, because I know you guys can look at graphs and tell me if they're positive or negative correlation. I want you to think about these. These are just real life scenarios. I want you to tell me if it would have positive correlation, meaning as one goes up, the other one goes up. Negative correlation, as one thing increases, the other thing decreases, or no correlation. The number of shots made and your distance from the basketball goal. I think we brought this one up yesterday, didn't we? Is this going to have positive or negative correlation? What's going to happen to the number of shots? What's going to happen to the number of shots you make as your distance increases from the goal? What's going to happen, Owen? It's going to get smaller. So as distance increases, our shots that are going in are going to decrease. This is a negative correlation. What about your language arts grade and the hours you spend reading? Lucy? That should be positive. Yeah, you would think the more you're reading, the better you are at reading or writing too. Okay. I became actually a really good writer, not to put any more pitches out, but I read The Lord of the Rings when I was in 8th grade. And I found myself when I was writing papers, writing more like the person I was reading or the books I was reading. And of course, he is a linguistics professor at Oxford, or was until he died. And so I've got really good at writing just from reading so much. And I didn't really like reading when I was a kid. I had to find the right thing. And I finally found my niche. I liked the Lord of the Rings books, and I had to find something else after that. But if you're one of those students that doesn't like reading, first of all, you do have to make time for it. And secondly, you have to find something you actually enjoy, because I'm not going to enjoy necessarily a non-fiction reading about something I don't care about. But fictional stuff, I feel like I can get into. My brain starts, like the Harry Potter books or Hunger Games books, or a lot of those series that you guys might have put your Panther bucks in. You can get into those pretty easily. And so if you didn't win those free books, sorry, you can check them out from the library or even your public library. It's going to have lots of books that you probably, how many of you guys have actually been to the Kokomo library? Okay, so most of you have. Okay. What about the Rocheville Library? I live just a few blocks down from Rocheville. It's like a 10-minute walk for me. There's books, there's Blu-rays and DVDs that you can check out. I mean, there's a lot that you can actually do from your public library, and it's free. You just gotta have an account, and you have to turn them back in. Jacoby. Yeah, so say you have to turn them in. Yeah.
I'm pretty sure we can go to libraries and like, I'm surprised that I'm not like blacklisted for libraries or something.
Hey, you're on the list. Actually, I've been more recently, I like listening to audiobooks while I mow and while I drive. And so I know you guys don't drive, but some of you guys might have chores. And so I've gotten audiobooks. I've listened to a lot of audiobooks over the summer. There's Lord of the Rings are on audiobook that you can check out. I checked them out from the Rocheville Library. So yes. Yeah. It comes to our daycare every couple of weeks and it parks right in the prime parking spot. So I've really started to hate the bookmobile, but I'm glad that you're getting something out of it because I'm just losing my parking space. So, all right, anyways, miles driven and driving time. As if you have to drive more miles, will it take you longer or shorter time to do that? Xander? Yeah, so as the miles you need to drive increases, your driving time is going to increase. If you have a shorter distance, you'll have a shorter time. Yes, Maddox? Time in the car. Yes. Yeah, so this is positive. Or I guess you can just say positive. Yeah, and you could flip it around and say, well, I don't have to drive very far. Okay, so if drive time decreases, your time in the car is also going to decrease. Student height and social studies grades. What do you think, Jace? Student height and social study grades. I would agree. There is no correlation there. If there was some sort of correlation, if I were to line you up from tallest to shortest, it would also reflect your social studies grades. We know that wouldn't be true. The age of a car and the value of the car. As the car increases in age, it's going to decrease in value. So it is a negative correlation. Obviously, there are a few outliers with cars that are older, but also much more expensive. Number of songs downloaded and the amount of memory on your phone available. Xander?
Negative.
Yeah, also negative. The more songs you have, the less memory you have available. You just stream them? Yeah, that seems to be the thing now, right? Pandora or Spotify or.
So much easier and it doesn't take up as much space.
You also have to have internet connection.
Not really.
Or good cell signal, both of which I didn't have when I was your age. So if I didn't have it on my phone, I didn't listen to it. Age of a house and number of people living in the house. Garrett, what do you think? The age of a house, what's going to happen to the number of people living in the house as the age increases? Sure. What, it increases as the house age increases? Well, hold on, I'm talking about people currently living in it. Okay, I misunderstood. No correlation. Yeah. Obviously, over time, more and more people have lived in the house. I'm talking about currently right now. There could be a family of 5 in a house that was built in 1984. There could be a family of 7 built in 2007. There could be a family of 14 living in a house from 2001. I mean, it's just random, right? It's going to be whatever is available, especially in the housing market we have right now. Houses are getting gobbled up left and right. All right, yeah, that should be no. Using a graph or its equation to approximate a value inside 2 known values is called interpolation. So if you're making a prediction within the data that you currently have, it's called interpolation. For example, if I was doing my alligator study, and instead of measuring the alligator every month, okay, let's go with every month. If I wanted to see what the prediction would be 2 weeks instead of 1 month, I don't have a data point for every 2 weeks. I only have data points for every single month. So that would be a prediction that's within the data that I have. Okay. If I'm tracking grades every chapter, but I wanted to make a prediction of what someone's grade was within the chapter, that would be interpolation. Okay. Using a graph or its equation to predict a value that's outside the range of known values is called extrapolation, or most people say extrapolation. Okay, so that's what we've been doing more of, is the extrapolation. They're saying, hey, here's our data so far. What do you think the data is going to be for this point all the way up here? We haven't gotten to that yet. That's extrapolation. If you're making a prediction for the future, it's extrapolation. If you're making a prediction for data that's within the data you already have, that's interpolation. It says the scatter plot shows the median ages of American women at their first marriage for selected years from 1960 to 2010. So the median age of when women were getting married. In 1960, they were just over 20 years old. That was your average, not your average, sorry, your median. That gets rid of all the outliers, right? Your median marriage age for your first marriage. In fact, they probably back then only had 1 marriage. That has been increasing. In fact, in 2010, the median marriage age for women has been closer to 26 versus 20. It's a 6-year difference. Okay. Back in 1960, they were probably already having their 4th child at that point, right? I don't know. They had a lot of kids back then. I feel like people don't have as many kids now. It's not as common a thing. Most families stop at 2 now. Is anyone a family of 2? I got me and my sister. It's a family, single child. How many of you guys are single child? Family of 3? Okay, family of 3. Family of 4? Ooh.
I have like 2 and a half siblings.
Family of 5? Now I'm talking about siblings. I'm not talking about adding your mom and dad to that. It's family of 5.
Siblings? Yeah, because I have 2 and a half siblings.
Siblings, no step siblings.
But what if your step sibling live with you?
Family of 6 or more.
Wait, what if your step sibling
How many?
live with you, though? Yeah, like, what if your step sibling?
Oh, okay. I'm sorry to hear that. But so 5, but had 6 at one point. Okay, interesting. And then stopped. You don't have another one? Okay. So yeah, that's not as popular. Back then it kind of was, especially in rural families, because what did the kids do growing up in the farm? Yeah, they worked the farm, right? Exactly. So, all right. It says.
My mom said that I was born only to turn off lights and give her the remote. She was kidding.
I know. Okay, hey, we need to finish this problem here. So it says use the points 20, 22, and 40, 25 to write an equation of the line at best fit. When you're writing an equation given 2 points, you should refer to point slope form. You'll remember point slope form as being y minus y1 equals m parentheses x minus x1. This is what we use anytime we're wanting to write the equation in slope-intercept form, but we don't know what the y-intercept is. So we use point slope form because they gave us 2 points. So we're going to calculate the m first. M is y minus y, or 25 minus 22, over x minus x, or 40 minus 20. What's 25 minus 22? 3. What's 40 minus 20? Okay. Then I'm going to plug it in. Do not pack up until you finish this. Y minus y1. Let's use the smaller points. So the y coordinate will be 22 equals 3/20 x minus, and then the x coordinate is 20. Well, that's going to work out nicely for us, because when you distribute the 3/20 to the x, you get 3/20 x. And when you distribute the 3/20 to the negative 20, the 20s are actually going to cancel out, and you end up with getting negative 3. 3/20 of 20 is 3. Add 20 to both sides. What's negative 3? Plus 20, because you have to add 20 to both sides. What is that? 17. Positive 17. So that would be the equation. Our y-intercept back in year 0 would have been hitting right around 17 on the y-axis. All right. We'll finish up tomorrow. Have a great day. All right, so to review real quick, we had a scatter plot of the ages of American women at their first marriage. It wanted us to write an equation in slope-intercept form of the trend line, or the line of best fit, that goes through the points 20, 22, and 40, 25. I guess we could have actually drawn that. 20, 22, and 40, 25. Which would be these 2 points, right? 22 here, I'm guessing. So it's 22 for the y, and then 25 for the y. So you might be thinking, why does it give us that weird 20 and then 40 for the x coordinate? Well, the 2022. No, I don't know for sure why they started with 20. I do know that the second dot is 20 years to the right, or 20 years in the future from where the first point was. I'm not sure why this. Oh, no, sorry. I thought we were going through this point here. Yeah, that makes sense. So if this is 0, sorry, video can't see me. If this is 0 right there on the y-axis, then this would have to be 10, and this one would have to be 20. So that makes sense why they'd say 20, 22. This one would have to be 30, and this one would have to be 40. So that makes sense why they'd say 40, 25. That's why they did that. Okay, I got caught looking at this point, which we're not even drawing our trend line through that point. So anyways, we used the 2 points to find the slope. Y1 or y2 minus y1 gave us 3. And x2 minus x1 gave us 20. So there's our slope, 3/20. We used the first point to plug in the x coordinate here. So plug in 20. Of course, it's already being subtracted in our original formula. And we plugged in 22 right there, which is also being subtracted from y. And that gave us the equation y equals 3/20 x plus 17. Now, must not have drawn a very good trend line because my trend line looks like it's going through at 19. Is that right? Do you guys see a mistake in this? Julia?
Why does the 22 turn into a 20?
That's a good question. It doesn't. So there is a mistake. Good eye. Julia, go get a sucker. I wish you'd have told me that yesterday. Yeah, so let's change that. This should be a 3 still. That should, no, wait, no. That should still have been a, no, that was 3. Yep. So that part was right. It was just this one that I needed to change. And so by adding 22 to both sides, that does give us 19. And that looks a little bit more like what we're seeing up in our graph right here, which looks like it's crossing right at 19 for that median age in 1960, even though we know it was actually closer to 20. My line of best fit is not going to be perfect, but it is going to give me an accurate or a predictive, a mostly accurate range for most of those data points. Some of the data points will be farther away from that line, but a lot of them are going to be pretty close to it. Now it says approximate the median marriage age in 1984. Is this interpolation or extrapolation? Well, in 1984, right around there, do we have a data point for that? We don't. Is it between data that we do have? Yes. So is this interpolation or extrapolation, Owen? It's interpolation. Yeah. We took a poll, looks like every 5 years, right? This was a survey every 5 years. 1984, we didn't do the survey, but it's within the data that we do know. So we're going to make a prediction. Now, if this is year 0, and this is year 10, and this is years 20, then we're looking at x equaling 24 for this one. 1984 is going to be x equals 24, or 24 years after they started calculating this. Okay, so we're going to plug in 24 into our equation y equals 3/20 x plus 19. So 3/20 times 24 plus 19. We can cancel the 20 and the 24 because this is just 24 over 1. 2 goes into 20 10 times, and 2 goes into 24 12 times. You can also take 2 out again to get 5 and 6, because 4 could have just gone in. And so that's going to leave us with 3 times 6 over 5 times 1. What is 18 divided by 5 as a decimal? It's probably going to be more helpful for us. Jimmy? 3.6. Okay, so it's 3.6 plus 19. And Jimmy, add 19 to that. And what would you say our median age is 1984 is? 22.6 years old. Yeah, we'll say years old age. No, let's just leave 22.6. Okay, so that was using interpolation. We can circle interpolation there. And then it says predict the median marriage age in 2020. Now, 2020, would that be interpolation or extrapolation? What do you think, Xander? Extrapolation, we're predicting for the future here. The last data point we have was 2010. Now, the year 2020 is how many years after 1960? Christian? 60 years. Okay. So now for this time, we're going to use x being equal to 60 because we're in the year 2020, which I know has already happened for us, but at the time of this data, it hadn't happened. Okay, so 2020, we're going to use x equals 60. So again, y equals 3/20. We're going to plug in 60 for our x coordinate plus 19. This time the 20 and the 60 will cancel out quite nicely. Sky, how many times does 20 go into 60? Okay, so 3 times 3 is 9, over 1 is just still 9, plus 19. Oliver, what's 9 plus 19? So 28, okay. So in the year 2020, they predict the median marriage age to be 28 for the first marriage. I don't know if I would agree with that. I feel like people get married before. Some don't. Some get married in their 30s for the first time, or even later. And then I see people that are getting married right out of college at 22 still. So, but that's the median. So we expect that number to be in the middle, and we expect there to be ages that are younger and also people that are older. They're getting married there. But eventually, this isn't going to go on forever. Like this is not going to be linear forever, because you're not going to, in the year 2407, you're not going to have a 99-year-old person getting married for the first time as their median age, right? That's not going to work. So at some point, this would have to become non-linear. But for what we're seeing right now, from 1960 to 2010, it appears to be linear. All right, that's it. All right, so